All right. Today we're going to start talking about what we call a conditional statement. We're going to see these statements all year long. And a conditional statement is simply an if-then statement. And these are something that we see every day. And we don't always say, oh, hey, that's a conditional statement I'm using right there. An example might be what we just talked about, right? If I didn't do well on my test, then I'm going to retake it. Okay, so this has to happen first, and then there is a conclusion to it. Something happens because of that. So this has to happen first, and then something happens because of that. So it's an if-then statement. Sometimes it could be geometry related. Doesn't even have to be a statement that's geometry related. I could say something like, if today is Tuesday, then it is the first day of the school week. Well, that's true this week, right? But in some weeks, that's not true. So sometimes that would be a true statement. Sometimes that would be a false statement. It just kind of depends on the week. Typically, Monday is the first day of the school week. So that would be an example of an if-then statement. If this, then this. So we call that a conditional statement. And the terminology or the generic terms that we use are if P, then Q. P and Q are the two parts that we're talking about. The symbol that we use for this is P arrow Q. And we just read that as the same thing. If P happens, then Q happens. But just like we did in chapter 1, we use a lot of symbols for the things that we do. And so that would be an example of what a conditional statement would look like. The hypothesis is the if part. So that's the P part. Okay? It's the if part. The conclusion is the ending statement based on what happens. So if I said something like, if today was Saturday, that'd be nice, huh? Then it is the weekend. If this is true, then this would always be true, right? Today is obviously not Saturday, so therefore it's not the weekend. But that's one thing that we're going to be looking at. Is it a true statement? First thing has to happen, and then the conclusion. Now, as I look at these down here, we're going to rewrite it as a conditional statement. Sometimes we already have if and then in it somewhere. Sometimes we don't. Okay? Right now, all we have is just a statement. All birds have feathers. We want to rewrite this as a conditional statement, which means we have to put it in if-then form. And sometimes we have to maybe add a little bit or maybe change things around to make it make more sense. Because right now, I don't just want to say, if all birds, then have feathers. Does that make any sense with what we said? No, right? And so it's not just simple as putting if and then into the statement to make it work. We got to try to make it work, okay? So we may even have to insert something a little bit different. So here, instead of saying if all birds, what could I say? If what?
Like if animals have feathers, then it's a bird.
Okay, you're close. Yeah, you're on the right track. I like the first part. If an animal, so we don't say anything about animals in the original statement, is a bird, then it has feathers. So we just kind of inserted the word animal. Okay. Last hour, somebody said, if it is a bird. Well, let's be a little bit more specific. It doesn't really describe it much. So something a little bit more descriptive would be good. Therefore, we add the word animal here. If an animal is a bird, then it has feathers. That would be something that would make sense in our mind, right? What's going on here. Doesn't necessarily mean it's true or false. And we will talk about that some today. But that doesn't mean this is necessarily true or false. Now, as we look at the second one, part B, if you are in Texas, or sorry, you are in Texas if you are in Houston. So this one already has the word if in here. So that means this right here is our hypothesis. It's not necessarily written first, right? But we're going to say if then you are in Texas. Okay, one thing to notice here. Another thing that it asks us to do here is identify the hypothesis and the conclusion. Hypothesis is my if part, the conclusion is my then part. Okay, part C, once again, it doesn't really make sense to say if all 30-degree angles, then acute angles, right? That doesn't make a whole lot of sense grammatically. So how could we rewrite that to make a little bit more sense? Okay, sounds good. If an angle is 30 degrees, then it is acute. This is hypothesis. This is the conclusion. And finally, this one, once again, doesn't have the word if and then in it, but we can see an equation working essentially the same way. If 2x plus 7 equals 1, then x equals negative 3. We could insert the words if and then and make it a conditional statement. This would be my hypothesis. This would be my conclusion. Okay, somebody asked me last hour, and it was a good question, can those two be flip-flopped? We don't really know what goes where. I think most cases, this is the way we want to write it, just like it is initially, unless you have the word if in there. Tomorrow we'll talk about flip-flopping the statement around a little bit and what we call that. But for right now, just a general rule of thumb, I would just stick with the way the original statement's written. All right, on this one here, we're going to talk about 4 different types of conditional statements. Really 3 different kinds, because the negation doesn't necessarily have to be a conditional statement. But when I hear the word negation, what does that bring to mind? What does that kind of sound like or think negative, right? I kind of think negative, since we're talking about a math class. And when I think negative, another word for negative would be like the opposite. If I have 3, a negative 3 would be the opposite of 3. So we use that word opposite sometimes. And that's what's happening here. It's going to give us the opposite of the original statement. And all we're going to do is insert the word not or take the word not out, one or the other, okay? And so my statement here would be not P. And the symbol that we use, here's that tilde sign again. I told you we're going to see that a lot throughout geometry. And in this case, it means not. So we read that simply as not P. Okay, the next 3 are taking the conditional statement and they're doing something to it. So we're going to take that original if-then statement and we're going to do 3 different things to it. So the first thing we're going to do is we're going to swap the hypothesis and the conclusion. So the conclusion becomes the hypothesis and vice versa. So the way I would read this one, if Q, then P. And my symbol would be Q arrow P. The P and Q have traded places. And we're going to look at some examples here in just a second. Okay, the inverse we're going to negate the hypothesis and conclusion. So we're going to go back to the original conditional statement, and we're going to negate both of them. Means we're going to insert the word not, or take the word not out if it's already in there. So this one is going to look like this. If not P, then not Q. My symbol for this one would be not P implies not Q. And then finally, the contrapositive is going to do two things. It's going to switch and negate. It's going to basically negate the converse. And so this one is going to look like this. If not Q, then not P. So we would say not Q implies not P. Okay, so those are the symbols that go with each one. And we will see that sometimes. You'll see it on Big Ideas when we have a Big Ideas assignment using these symbols and statements. So it's good to know them and know what they mean and how to use them. This right here in this box is a really important statement. I'm going to put a star by it because this can really help you when you determine truth values. Okay, that's why we're putting it here. We're going to ask you to determine if the statement is true or false. And not only the original statement, but all four statements. Because we're going to have a conditional, a converse, an inverse, and a contrapositive. And here's what you need to know. The conditional and the contrapositive are always the same truth value. They're either both true or both false. So the one that we start with at the beginning and the contrapositive at the very end are always going to have the same truth value. Same is going to be true for the converse and the inverse. These two are either both true or both false. So the way that I kind of remember it is the two that end in verse will always have the same truth value. And then the other two, the conditional and the contrapositive, will always have the same truth value. Okay, and I'll show you how that works, but I'll show you why it's easy. If you can remember that piece of information, that's going to make your truth value in determining if it's true or false much, much easier. Okay? All right, so first statement here, negation of each statement. Notice this is not written in if-then form. Not all of these statements have to be written in if-then form. This is just simply a statement, the ball is red. I want to give it its opposite truth value. So what would be the exact opposite of saying the ball is red? The ball is not red, okay? I don't want to make up a new statement and say the ball is blue, right? I just want to cover everything that is anything but red, right? So we simply just say the ball is not red. That covers everything that's not red. If the word not is already in there, we're simply just going to take it out. If I said the cat is not black, then the opposite of that would be the cat is black. We're not putting it in if-then form. We're just rewriting the statement, either inserting the word not or taking the word not out if we're doing a negation. Okay, this part here is where it starts to become like an English class, right? It's different than any other math class because we do things different in geometry than we do in algebra or any other math class. Today we're going to be writing a lot of statements, a lot of sentences out based on a given piece of information. So here, for parts A, B, C, and D, we're going to write 4 different sentences with 4 different meanings, essentially, okay? The first one we're going to start with is the conditional statement, the original if-then statement. They give me a statement for P, they give me a statement for Q, so we're just going to simply put the words if and then and write it as an if-then statement, okay? So we're going to say if you are a guitar player, then you are a musician. Okay, I'm not going to do the truth value right now. I want to do all four statements first, and then I'll come back and determine true or false last. Okay, second statement is the converse. The converse takes the two statements and flip-flops them. Okay, so now we're going to say, if you are a musician, then you play guitar. That's my second statement. The third statement is what we call the inverse. The inverse is not P implies not Q. So we're going to go back to our original conditional statement, and we're going to insert the word not in here. If you are not a guitar player, then you are not a musician. Okay, finally, we're going to do both. We're going to flip it and we're going to negate it. Okay? We're going to say, if you are not a musician, then you are not a guitar player. Those are my four statements. Okay, the last thing it's asking me here is decide whether each statement is true or false. So we're going to read the statement, we're going to decide if it's true or false. If it's true, that means it's always true. If it's false, that means I can find an example that proves or shows that it's false. Okay? We call that a counterexample. It's an example that goes against the statement. It proves it false. If you are a guitar player, it means I play the guitar. Does that make me a musician? Yeah. Okay, doesn't necessarily mean you're great at it, but if you can strum away on the guitar, then that means you can be considered a musician. Okay, if this one is true, I immediately can say the contrapositive is true. And where that's helpful, that's in that box up above, the one I told you to star. These two always have the same truth value. So if I know this one's true, I know this one's true. This gets a little bit tricky when the word not is in there. And that's why I like just saying, okay, if this is true, I can immediately know this one's true. And you don't even have to kind of read through it and try to get understanding what it means. Because the word not can get a little bit confusing in some cases. Okay? Then we're going to look at the converse. If you are a musician, that means you play the guitar. Do all musicians play the guitar? No. Okay? So that would be a false statement. If I wanted to find a counterexample, I could say someone that plays the trumpet. Someone that plays the trumpet is a musician because they play an instrument, but they're not necessarily a guitar player. And then if that one's false, then this one would also be false. Those two middle statements will always have the same truth value. Once I decide one of them's false, I know the other one immediately. Okay. Here's what I want you to do. Try writing out the 4 statements here on your own, okay? I'm going to do it as you guys are doing it, and then we'll compare. Do it just like we did the last one. Hey, Mr. Elder.
I think that's your new TV you for your presentation next Wednesday.
Not me.
Not me either, but it helps keep the smile out of me.
At some point, I know I'm up.
At some point, I'm up too.
Yeah.
Not
Yeah.
Wednesday.
I'm pretty sure I'm second semester, so.
I think I am.
And I know that because Brian's like.
You got it, okay, well, I gave him the same book, just a minute.
Well, at least we don't have to share, right?
Yeah, you don't have fun.
Thank you.
It's not.
Okay. Who wants to take the conditional? Yeah.
If the star is visible, then it is
Okay. Yep. And conditional is usually one of the easier ones because we're just putting if and then in there with the P and the Q that we're given at the front. Okay. So if stars are visible, then it is night. Okay. We'll come back to the truth statement here in just a second. Okay. Converse. Yeah.
If it is night, then the stars are visible.
Okay. Good. Okay. Inverse. Owen, did you get it? Inverse?
I didn't get it.
You didn't get it?
If
Tris?
you can't see
Yeah.
the stars, then it is not night.
Okay. Okay. And then D, the contrapositive. Sophia?
If it is not night, then the stars are not.
Okay, there we go. Those are our 4 statements. Okay. Now, let's determine truth value of each one of those. If you need to double check yours, that's what it should look like. As we go back up here then, if the stars are visible, then it is night. True or false? True. Okay. If I can see the stars, that means it's nighttime. If it is night, then stars are visible.
False.
Okay, how come? Do what?
Because they're not always visible.
Why? How come? Why are they not visible?
Just the weather.
Yeah. What'd you say? Pollution would be good. Okay, so pollution or cloudy or something like that. So that would be a reason why maybe we can't see it. It doesn't mean it's not nighttime, right? We might look up in the star. That's why sometimes like when they have, meteor showers and things like that, you can't always see all of those things because of, the conditions that night. How clear is it going to be? That kind of thing. Which means this one also has to be false. And since the first one was true, this one's true. Okay? I really feel like that's the best way to do it because when we start reading the word not, that gets really confusing, and I would rather not have to determine the truth value with those words in there, because that gets a little bit tricky. Okay, sometimes, like this one up here with the stars and everything, didn't have anything to do with geometry, right? So sometimes you're like, what's that have to do with geometry? Really, it's just practice writing a conditional statement. But a lot of things that we do in geometry will use those conditional statements. Now, what I will tell you is sometimes we're going to see some things that we haven't even seen yet, because they're going to give us a statement and we have to determine if that statement is true or false. But we haven't seen some of the symbols. And so one of those symbols is the upside down T. Anybody ever seen that symbol before? Yeah. What do you think? You think you know what it means? No? You've seen it? Okay. We haven't seen it yet this year, but it's going to be something we're going to see a lot. Okay? So this means perpendicular. Okay? And perpendicular means 90-degree angles. Two lines that form a 90-degree angle. So immediately on part A, we see that symbol. And the way that we're going to read this is AC is perpendicular to BD. And what we're trying to determine, is that a true statement or a false statement? Do I know without a doubt that those two lines form two perpendicular lines? Okay? Why would you say yes, Natalie?
Because they cross and they divide it into four sections of two straight lines that intersect.
Okay? Do we know for sure that there's a 90-degree angle there?
There's a little box.
There's a little box. There you go. Okay? This little symbol is the key. Okay? Whenever I see this little corner, this little box in the corner, that means those two are forming a 90-degree angle. They don't ever have to say, hey, this is 90 degrees, but when I see that symbol, that's going to be my dead giveaway. Okay? So on this one, we would say true, because they form a right angle. Okay, here's another one. Bisects. If two things bisect, what does it mean to bisect? Okay, they cross, and what happens when they cross? Okay, so if I said that E bisects AC, segment AC, is that true or is that false? Does it appear that E is halfway in between A and C? It looks like it, right? Can I say without a doubt, I know 100% that that's true? No. What would tell me that that's the case? What would I need to be given? Yeah, I could tell you this and say those two markings are the same. Okay, I could tell you that this is 7 and this one is 7. I could put the actual measurements in there, right? But we don't have any of that. So one of the hardest things about geometry is we're going to be given a picture, and it sure enough looks like E is in the middle, right? But we don't have enough information to prove that. So if we don't have enough information to prove it, then sorry, we can't do it, right? And so here we have to say false. We need info about the length. I kind of, and I'll use this comparison a lot. When we start talking about doing all these different kinds of reasoning. If someone is charged with some type of crime, then what they have to do is they have to go sit at a trial. And what do they have to prove? That they're guilty, right? You're not going to show up to court and say, yep, you're guilty, sorry, we're not even going to have a trial. You're going to jail, right? They got to prove. They got to have some evidence. They got to have some data. They got to show why they think this was the person that did it. Then if they truly get found guilty, then they'll go to jail. But same thing here. We have to prove without a shadow of a doubt that that's true. We can't just assume they're true, right? We got to prove it. Okay, here's another definition. And we're going to see a lot of these definitions, guys, okay? And in these definitions, what we have to prove is if that's true or not. You may have to go back to some of your stuff in chapter 1, because it's been a while since we've talked about some of these things, like opposite race. That's something we talked about in chapter 1 that we bring it back up again here. What is true about opposite race? What do they make?
180.
They make 180. They make a line. Exactly. Okay? So if I go EA and EB, do those two form a line? No. They form a right angle. They need to form a line. So this one, once again, is false. And then you could just say something, they don't form a line. They both start at E, which is good, but they're not going opposite directions from one another. Okay, so sometimes those true false ones are a little bit tricky. Here's a couple more. They give us a picture, and we have to determine, is that true or false? And then here's the big part. Explain why. So like on a quiz or a test, it's not just a 50-50 shot, right? If you say true, then you can back it up. Or if you say false, you can back it up. Tell me why you think it's true or why you think it's false. Give me a little bit of information to kind of show me that you know exactly what you're talking about. So in this case here, JMF, be that angle right there, angle JMF, angle FMG. Then we got to remember what the word supplementary means. What does it mean to be supplementary? They form 180, right? Do those two angles together form 180? Yeah, they make a line, right? And so here we would say yes or true because they are a linear pair. There's another. You can use a definition to prove what we're talking about. A linear pair is a pair of angles that form a line. One of the questions on the test last week, and this was probably the most missed one on the entire test. It was like one of the very last questions, maybe the last question besides the extra credit. It said, name a pair of supplementary angles. And I had a lot of people that just said BAD. BAD is one angle, okay? We need to name a pair. So you have to give me two. Pair means two. If you just said one angle, what is that going to be supplementary with? So you have to identify, if I say pair, I'm looking for two things, okay? So you got to read those questions carefully. I'm not just asking you to name a supplementary angle, a linear or a line. Name two angles that make that line. So that's just something I was thinking about from grading the test this weekend. Is point M the midpoint of FH? Is M right between F and H? Does it look like it? Oh, if it looks like it, we can just say yes, right? No. Okay, it's a trick, right? It's a little trick. And pictures are deceiving because when we look at it, we're like, sure looks like it's in the middle, right? Doesn't mean it is. Okay, we have to have some proof. So once again, I would need some markings. We kind of talked about this one just a second ago. We would have to say false here. I need markings. It doesn't mean that it's not. M truly could be, but I just don't know. I can't say yes or no, so I have to say false. I need more information. Okay, vertical angles. Here's another one we haven't talked about for a while. JMF is this angle here. HMG is this angle here. Vertical angles, we haven't seen it for a little bit. Vertical angles, how do I know that two angles are vertical? They have to be what? Not necessarily. Right now, we don't know vertical angles very well. This will be an angle that we talk a lot about as we go throughout the year. How do I know these two are vertical? True or false?
There's a right angle.
They what?
There's a right angle.
Could be, but it doesn't have to be. They have to be what? Anybody remember?
Oh, we form an X.
They form an X. Okay. So it's two angles directly across from one another when they form an X. So are these two directly across from one another? Yeah. Okay. So this would be true. Okay. And that is one that's in chapter 1. So you may have to go back and look at some of your vocab from chapter 1. It'd been a while since we talked about it. So I get that we didn't remember that, but we've got to make sure we know exactly what vertical means before we can say true or false. Okay, finally, what's the upside down T mean? Perpendicular, okay? So the way we're going to read this is FH, line FH, perpendicular to line JG. In order for these two to be perpendicular, what do they have to form? Okay, right angle. So does it look like these two form a right angle? Maybe, okay? Do we know that for sure? No, okay? So we have to say false. What would I need? I need a box. Yep, I need that 90-degree marking. If I were to put this box here, then we would be good, right? But because I don't have that box in there, I need a 90-degree marking to show that, okay? So don't just look at it and say, oh yeah, looks like that's true. All right, so that's day 1. Day 2 is continuation